What if the most mysterious object ever to enter our solar system wasn't just a random piece of space debris, but humanity's first confirmed encounter with alien technology? What if ʻOumuamua, that strange, elongated visitor that swept past Earth in 2017, was actually an engineered probe sent by an advanced civilization to study our world? Tonight, as you drift into the deepest cosmic mysteries, we're going to explore the controversial theory that shook the scientific community to its core. Harvard's most distinguished astrophysicist staked his reputation on the claim that we were visited by our first piece of extraterrestrial technology, and the evidence he presents might change how you see our place in the universe forever. Before we dive into this paradigm-shifting investigation, make sure you are subscribed, because what you are about to discover could represent the most important moment in human history, and most of the world still doesn't know it happened. Let's begin this extraordinary investigation by traveling back to October 19, 2017, when a Canadian astronomer named Robert Weryk made a discovery that would challenge everything we thought we knew about our cosmic neighborhood. Picture the Pan-STARRS telescope perched atop Haleakala Observatory in Hawaii, its mechanical eye scanning the heavens with automated precision. On this particular night, as stars wheeled overhead and the Earth turned beneath them, the telescope captured something that shouldn't have been there: a faint point of light moving against the background of distant stars with impossible speed. When first observed, one eye, ʻOumuamua, was about 33 million kilometers from Earth, roughly 85 times the distance to the Moon, and it was already heading away from the Sun at tremendous velocity. The object had passed its closest approach to our star 40 days earlier, on September 9, 2017, and astronomers had missed its arrival entirely. The Hawaiian name ʻOumuamua means scout, or messenger from afar arriving first, and as scientists began analyzing this cosmic visitor, they realized that the name was more prophetic than they could have imagined. This was no ordinary asteroid or comet. It was the first confirmed interstellar object ever detected passing through our solar system. As observations poured in from telescopes around the world, ʻOumuamua revealed properties that were unlike anything in our cosmic experience. The object was small, estimated to be between 100 and 1,000 meters long, roughly the size of a skyscraper laid on its side. But its shape was what truly set it apart from every other natural object we'd ever observed in space. ʻOumuamua was extraordinarily elongated, with an aspect ratio of at least 5.1, and possibly as extreme as 10. 1. Imagine a cosmic cigar, tumbling end over end as it raced through the solar system at speeds that spoke of its interstellar origin. No known natural process easily explains how such an extremely elongated object could form and maintain its structural integrity during the violent journey between stars. But the strangeness didn't end with its shape. As ʻOumuamua passed through our solar system, astronomers expected to see the telltale signs of cometary activity: a glowing coma of gas and dust, a magnificent tail streaming away from the sun as solar radiation vaporized the object's icy exterior. Instead, they saw nothing. ʻOumuamua showed no signs of outgassing, no coma, no tail. It appeared to be completely inert, more like a metallic asteroid than an icy comet. Yet when scientists analyzed its trajectory with exquisite precision, they discovered something that violated their expectations once again. ʻOumuamua was accelerating away from the sun in a way that couldn't be explained by gravity alone. The trajectory exhibited an anomalous non-gravitational acceleration away from the sun with no sign of cometary evaporation. The magnitude of this mysterious acceleration was tiny, about 5 micrometers per second squared, roughly the acceleration you'd feel if a feather were gently pushing against your back. But in the precise calculations of celestial mechanics, this small deviation was enormous. Something was pushing Oumuamua, and conventional physics couldn't explain what. For most astronomers, this anomalous acceleration suggested that Oumuamua must be a comet after all, perhaps outgassing material so sparsely that it was invisible to our telescopes, yet still sufficient to provide the gentle push observed in its trajectory. But one Harvard astrophysicist saw something entirely different in these mysterious properties. Dr. Avi Loeb, the Frank B. Baird Jr., professor of science at Harvard University and former chair of Harvard's astronomy department, looked at Oumuamua's extreme elongation, its lack of cometary activity, and its anomalous acceleration, and reached a startling conclusion. To Loeb, the most plausible explanation was as obvious as it was sensational. Taken together with its possibly pancake-like shape and high reflectivity, Oumuamua's anomalous acceleration made perfect sense if the object was in fact a light sail, perhaps a derelict from some long-expired alien civilization. As you settle deeper into this cosmic mystery, consider the profound implications of Loeb's hypothesis. If Oumuamua was indeed artificial, a piece of technology created by intelligent beings, then humanity had just experienced its first confirmed encounter with extraterrestrial engineering. We had been visited, studied, and passed by, all while barely managing to notice the visitor's presence. The scientific community's reaction to Loeb's proposal was swift and largely dismissive. The idea that we had been visited by alien technology seemed too extraordinary, too paradigm-shifting to accept without overwhelming evidence. But, as Loeb would repeatedly point out, extraordinary claims require extraordinary evidence. And Oumuamua's properties were extraordinary by any measure. This brings us to the heart of the scientific controversy that divided the astronomical community, the light sail hypothesis that could prove we are not alone in the universe. As we delve deeper into the mystery of Oumuamua, we arrive at one of the most controversial scientific hypotheses of the 21st century. The possibility that this strange visitor was not a natural object at all, but an artificial light sail created by an advanced alien civilization. To understand why this idea is so revolutionary, we must first grasp the elegant physics of light sails, a propulsion technology that exists at the intersection of our most advanced engineering and the fundamental forces of nature. Light carries momentum, and when photons strike a reflective surface, they impart a tiny but measurable push. This radiation pressure, though weak, can accelerate objects in the vacuum of space without requiring any fuel or propellant. Human engineers have already successfully deployed light sails in space. The Japanese probe Ikaros, launched in 2010, used a gossamer-thin membrane to sail on sunlight across the inner solar system. These technological demonstrations prove that light sail propulsion is not science fiction, it's science fact, limited only by our ability to create materials that are both lightweight and durable enough to survive the journey between worlds. But an interstellar light sail would represent technology far beyond our current capabilities. To travel between stars using radiation pressure alone, such a device would need to be incredibly thin, perhaps just a few atoms, thick yet strong enough to maintain its structural integrity across the vast emptiness of interstellar space. It would need to be engineered with a precision that pushes the boundaries of what we consider possible. When Dr. Avi Loeb analyzed Oumuamua's properties through the lens of light sail physics, he found that the pieces fit together with remarkable consistency. The object's extreme elongation could be explained if it were actually a flat, pancake-shaped membrane viewed edge-on, like looking at a dinner plate from the side, which would appear as a thin line. This geometry would maximize the surface area exposed to stellar radiation while maintaining the elongated appearance observed from Earth. the anomalous acceleration that puzzled astronomers becomes elegantly explicable if Oumuamua were indeed a light sail. As the object passed close to the Sun, solar radiation would have pushed against its reflective surface, imparting exactly the kind of gentle, non-gravitational acceleration observed in its trajectory. The magnitude of this acceleration, about 5 micrometers per second squared, matches what theoretical calculations predict for a thin, lightweight sail of Oumuamua's estimated size. Most importantly, the light sail hypothesis explains why Oumuamua showed no signs of cometary outgassing despite its acceleration. Unlike a comet, which accelerates by venting gas and dust into space, a light sail accelerates purely through the pressure of electromagnetic radiation. There would be no visible coma, no spectacular tail, just the silent push of starlight against an engineered surface. But perhaps the most intriguing aspect of Loeb's hypothesis is what it implies about the object's origin and purpose. If Oumuamua was indeed an artificial light sail, it might not have been sent to our solar system deliberately. Instead, it could be a piece of technological debris, the remnant of some ancient alien civilization's space program, tumbling through the galaxy like cosmic flotsam. Imagine an advanced civilization that mastered interstellar travel using fleets of light-powered spacecraft. Over millions or billions of years, some of these vessels might have been abandoned, damaged, or simply reached the end of their operational lives. Like the countless pieces of space debris now cluttering Earth's orbit, these derelict light sails could be drifting through the galaxy in vast numbers, occasionally passing through star systems like cosmic ghosts. From this perspective, Oumuamua might represent our first glimpse of what Loeb calls the SETI, the space archaeology of extinct civilizations, physical evidence of technological species that lived, thrived, and vanished long before humanity ever looked up at the stars. The object's tumbling motion, its apparent lack of active control systems, and its hyperbolic trajectory all suggest a derelict rather than an active probe. Yet the possibility remains that Oumuamua could have been something more deliberate, a reconnaissance probe designed to study our solar system and report back to its creators. Such a probe might be programmed to appear inactive while conducting passive observations, gathering data about our sun, our planets, and perhaps even the unusual radio transmissions emanating from the third planet's surface. The light sail hypothesis also raises profound questions about the prevalence of such objects in our cosmic neighborhood. If Oumuamua represents alien technology, and if it's not unique, then our solar system might be regularly visited by similar artifacts. The fact that this was the first such object we detected might say more about the limitations of our observational capabilities than about the rarity of interstellar visitors. As you contemplate this possibility, consider what it would mean for humanity's place in the cosmic order. We've always assumed that if extraterrestrial intelligence exists, first contact would be dramatic. Radio signals from space, massive ships in Earth's sky, or some other unmistakable announcement of their presence. But what if first contact has already happened, quietly and subtly, in the form of ancient technological artifacts drifting through our solar system like messages in cosmic bottles? The elegance of the light sail explanation lies not in its exotic nature, but in its simplicity. It requires no new physics, no revolutionary discoveries, just the application of well-understood principles of optics and engineering to an object whose properties perfectly match what such technology would look like from our distant perspective. But if Oumuamua truly was an alien light sail, what does this tell us about the civilization that created it? And what other explanations have scientists proposed for this mysterious visitor's strange properties? As word of Dr. Avi Loeb's light sail hypothesis spread through the scientific community, it triggered one of the most heated debates in modern astronomy. The suggestion that Oumuamua might be alien technology didn't just challenge our understanding of a single mysterious object. It challenged the fundamental assumptions that govern how scientists approach the search for extraterrestrial intelligence. The reaction from Loeb's colleagues was swift and largely critical. Many astronomers argued that invoking alien technology to explain Oumuamua's properties violated Occam's razor, the principle that the simplest explanation is usually correct. From their perspective, it was far more reasonable to assume that this interstellar visitor was a natural object with unusual but explicable characteristics than to leap to the conclusion that humanity had encountered its first piece of extraterrestrial engineering. Critics proposed alternative explanations for Oumuamua's anomalous acceleration. Some suggested that the object might be a hydrogen iceberg, a chunk of solid hydrogen that formed in the cold depths of interstellar space. As such an object approached the Sun, the hydrogen would sublimate so gradually that the outgassing would be invisible to our telescopes, while still providing enough thrust to account for the observed acceleration. Others theorized that Oumuamua could be a fragment of a larger planetary body, blasted into space by some cosmic catastrophe in its home star system. The object's extreme elongation might result from the violent forces that created it, while its lack of visible outgassing could be explained by an unusual composition or surface properties that do not match typical comets or asteroids. But Dr. Loeb remained undeterred by the criticism, arguing that his colleagues were allowing scientific conservatism to blind them to extraordinary possibilities. In his view, the astronomical community had become so risk-averse that it was unwilling to seriously consider hypotheses that challenged conventional wisdom, even when those hypotheses provided better explanations for observed phenomena. The controversy intensified when Loeb published his analysis in peer-reviewed journals and later expanded his arguments in a popular book titled Extraterrestrial: The First Sign of Intelligent Life Beyond Earth. His willingness to take his case directly to the public, bypassing the traditional gatekeepers of scientific discourse, further inflamed tensions with his academic colleagues. What made the controversy particularly intense was Loeb's stature in the scientific community. This wasn't a fringe theorist or publicity-seeking researcher making wild claims. It was the former chair of Harvard's astronomy department, a distinguished scientist with hundreds of published papers and a reputation for rigorous scholarship. When someone of Loeb's caliber stakes their professional reputation on such an extraordinary claim, the scientific community has no choice but to take notice. The debate revealed deep philosophical divisions within astronomy about how to approach the search for extraterrestrial intelligence. Traditional SETI, search for extraterrestrial intelligence efforts, have focused primarily on radio signals and other forms of deliberate communication from alien civilizations. But Loeb argued for what he calls space archaeology, the search for physical artifacts and technological debris that might reveal the presence of extinct or distant civilizations. From Loeb's perspective, space archaeology might actually be more likely to succeed than traditional SETI approaches. While an alien civilization might choose not to broadcast radio signals in our direction, or might use communication technologies we haven't yet invented, they would inevitably leave physical traces of their technology scattered throughout the galaxy. These artifacts would persist long after their creators had vanished, providing a more durable record of technological intelligence than any radio transmission. The controversy also highlighted the challenge of applying scientific methodology to unique events. Oumuamua will never return to our solar system for follow-up observations. It's already beyond the reach of our most powerful telescopes, racing away into the depths of interstellar space. This leaves scientists in the unusual position of trying to understand a phenomenon they can never directly study again, based on just a few weeks of observations from a single encounter. Critics argued that this limited dataset was insufficient to support such extraordinary conclusions. They pointed out that many aspects of Oumuamua's properties remained uncertain. Its exact size, shape, composition, and internal structure were all based on indirect observations and theoretical modeling. How could anyone claim with confidence that this object was artificial when so much about it remained unknown? But Loeb countered that uncertainty works both ways. If scientists couldn't definitively prove that Oumuamua was natural, then they shouldn't categorically reject the possibility that it might be artificial. In his view, the proper scientific approach was to consider all hypotheses that fit the available data, regardless of how challenging they might be to conventional thinking. The debate extended beyond the properties of a single object to encompass broader questions about the nature of scientific inquiry itself. How willing should scientists be to consider extraordinary hypotheses? What constitutes sufficient evidence for paradigm-shifting claims? And how should the scientific community balance skepticism with openness to revolutionary discoveries? As the controversy raged in academic journals, conference presentations, and public forums, it became clear that Oumuamua had become more than just a mysterious interstellar visitor. It had become a mirror reflecting the hopes, fears, and philosophical commitments of the scientists trying to understand it. This scientific battle over Oumuamua's true nature raises a profound question. What would alien technology actually look like if it visited our solar system? And how would we recognize it when we see it? As we continue our investigation into the possibility that Oumuamua represents humanity's first encounter with extraterrestrial technology, we must grapple with a fundamental challenge that has haunted the search for alien intelligence. How would we actually recognize alien technology if we encountered it? This question goes to the heart of one of science's most profound conceptual difficulties. When we imagine alien technology, we inevitably project our own technological assumptions and limitations onto hypothetical extraterrestrial civilizations. We picture alien spacecraft that look like advanced versions of our own rockets, or communication systems based on enhanced versions of our radio technology. But truly, alien technology might operate on principles we haven't discovered, or might have evolved along pathways so different from our own that we wouldn't immediately recognize it as artificial. Consider the possibility that an advanced civilization might have developed beyond our current technological paradigm entirely. While we're still struggling to master chemical rockets and are just beginning to experiment with light sails, a species with millions of years of technological development might have moved to engineering approaches that seem like magic to us. They might manipulate space-time itself, harness dark matter and dark energy, or work with physical principles that our science hasn't yet uncovered. From this perspective, Oumuamua's strange properties might actually be evidence of technology so advanced that it operates at the edge of our ability to comprehend it. The object's extreme elongation might not be the result of natural formation processes or conventional engineering, but might reflect construction techniques that optimize for physical principles we don't yet understand. But there's another possibility that Dr. Loeb has emphasized. We might be most likely to encounter not the pinnacle of alien technology, but its discarded remnants. Just as archaeologists study ancient human civilizations by examining their pottery shards and broken tools rather than their greatest masterpieces, space archaeologists might learn about alien civilizations primarily through their technological waste. If interstellar space is littered with the debris of countless vanished civilizations, broken light sails, derelict probes, fragments of artificial materials that retain their engineered properties across cosmic time, then objects like Oumuamua might represent our most realistic opportunity to study alien technology. these artifacts wouldn't be the advanced, actively controlled systems of living civilizations, but the fossilized remnants of technologies that once served purposes we can barely imagine. This archaeological perspective suggests several criteria we might use to identify artificial objects in space. First, statistical anomalies. If artificial debris is scattered throughout the galaxy, we might occasionally encounter objects whose properties are so unlikely to occur naturally that they suggest engineering. Oumuamua's extreme elongation, combined with its lack of cometary activity and anomalous acceleration, might represent exactly this kind of statistical signature. Second, we might look for materials or structures that require deliberate manufacturing. Natural processes tend to create objects with certain characteristic properties, specific ranges of density, composition, and structural organization that reflect the physical forces that shaped them. Objects that fall outside these natural parameters might indicate artificial origin. Third, we might search for functional integration, the hallmark of designed systems where multiple components work together to achieve purposes that wouldn't emerge from random natural processes. A natural rock or ice fragment might have unusual properties, but it's unlikely to exhibit the kind of coordinated functionality that characterizes even simple human tools. When we apply these criteria to Oumuamua, intriguing patterns emerge. The object's properties don't just individually deviate from natural expectations. They seem to work together in ways that would make sense for a designed light sail. The extreme thinness maximizes surface area for radiation pressure, the lack of outgassing eliminates the need for propellant, and the tumbling motion might represent the natural state of a derelict sail that has lost attitude control. But recognizing alien technology also requires us to overcome our anthropocentric biases about what technology should look like. Human technology tends to be obviously artificial. We build with straight lines, smooth surfaces, and geometric patterns that rarely occur in nature. But aliens might have evolved aesthetic and engineering preferences that make their technology blend more seamlessly with natural forms. An alien civilization that developed on a world where biological forms dominated might create technology that mimics organic shapes and processes. Their light sails might look like cosmic jellyfish, their probes might resemble metallic seeds, and their larger constructions might follow patterns inspired by their homeworld's ecology, rather than geometric principles familiar to human engineers. The challenge becomes even more complex when we consider the possibility of self-replicating or self-repairing alien technology. Such systems might be designed to adapt and evolve over time, potentially developing characteristics that their original creators never intended. A probe that has been traveling through interstellar space for millions of years might bear little resemblance to the technology that was originally launched, having rebuilt itself multiple times using materials encountered during its journey. This evolutionary perspective raises the possibility that some artificial objects might become so modified by time and circumstance that they're virtually indistinguishable from natural phenomena. They might represent a kind of technological evolution that has reached an equilibrium with natural forces, creating artifacts that seem natural but retain subtle signatures of their artificial origin. As you contemplate these possibilities, consider that our cosmic environment might be far richer and more complex than we typically imagine. Instead of a largely empty space punctuated by occasional natural objects, the galaxy might be filled with the technological artifacts of countless civilizations, a cosmic museum of engineering approaches and design philosophies that span millions of years and thousands of different evolutionary pathways. This brings us to a crucial question. If Oumuamua truly was our first confirmed encounter with alien technology, what does this tell us about our cosmic neighborhood and the civilizations that might inhabit it? As we drift deeper into the profound implications of Oumuamua's possible artificial origin, we arrive at perhaps the most mind-expanding aspect of this cosmic mystery: what it would mean if humanity has already experienced first contact with extraterrestrial intelligence, and we almost missed it entirely. If Dr. Avi Loeb's hypothesis is correct, then October 2017 represents one of the most significant moments in human history. Our species' first confirmed encounter with technology created by beings from another world. Yet this momentous event passed with barely a whisper of public awareness, noticed only by a handful of astronomers who watched a strange object tumble silently through our solar system before disappearing forever into the cosmic dark. This scenario forces us to reconsider everything we thought we knew about how first contact might unfold. Science fiction has conditioned us to expect alien encounters to be dramatic, unmistakable events. Massive ships appearing over major cities, deliberate radio transmissions spelling out mathematical sequences, or direct attempts at communication that leave no doubt about their artificial origin. But ʻOumuamua suggests that real first contact might be far more subtle, ambiguous, and easy to overlook. The object's behavior pattern raises fascinating questions about the intentions and methods of its hypothetical creators. If ʻOumuamua was indeed an engineered probe, it showed no signs of attempting to communicate with us, no obvious efforts to make its artificial nature known, and no apparent interest in establishing any kind of relationship with human civilization. It simply observed, measured, and departed. A cosmic scientist conducting research on specimens that remained largely unaware they were being studied. This passive observational approach might reflect a kind of cosmic anthropology, a deliberate policy of studying developing civilizations without interfering in their natural evolution. Advanced aliens might have learned that direct contact with less developed species can be disruptive or harmful, leading them to adopt protocols that prioritize observation over communication. From this perspective, ʻOumuamua might represent one element of a vast, ongoing scientific project: the systematic study of emerging intelligence throughout the galaxy. Earth might be visited regularly by similar probes, each one designed to gather specific types of data about our planet's geological evolution, biological development, and technological progress, without revealing their presence to the subjects of their research. But the implications extend far beyond the possibility of being studied by alien scientists. If objects like ʻOumuamua are common, if interstellar space is filled with technological artifacts from various civilizations, then our solar system might be far from the quiet, isolated backwater we've always assumed it to be. Instead, we might inhabit a cosmic highway where the technologies of countless species regularly pass through our neighborhood. The statistical implications of discovering even one such object are staggering. Astronomers estimate that we detect only a tiny fraction of the interstellar objects that actually pass through our solar system. Most are too small, too dark, or move too quickly to be noticed by our current survey telescopes. If ʻOumuamua represents alien technology, and if we were lucky enough to spot just one such artifact, then there might be thousands or millions of similar objects that pass through our cosmic neighborhood undetected. This perspective transforms our understanding of galactic civilization entirely. Instead of imagining isolated worlds scattered throughout empty space, we might inhabit a galaxy where technological artifacts flow between star systems like a vast circulatory system carrying information, materials, and perhaps even living organisms from world to world. The Milky Way might be far more interconnected than we ever dared imagine. The timing of ʻOumuamua's discovery also raises intriguing questions. The object was detected just as humanity reached the technological capability to spot and study such visitors. Is this coincidence, or might there be some deeper connection? Perhaps the probe was designed to become detectable only when a civilization reaches a certain level of astronomical sophistication. a kind of cosmic graduation test that reveals itself when a species demonstrates sufficient scientific maturity. From a more philosophical perspective, the possibility that we've encountered alien technology forces us to confront fundamental questions about humanity's cosmic significance. If we're being studied by advanced aliens, what does this say about our role in the galactic community? Are we primitive specimens in some vast laboratory, or developing partners in a cosmic civilization that we're only beginning to glimpse? The psychological implications are equally profound. How would human society change if it became widely accepted that we've already been visited by alien technology? Would this knowledge inspire us to greater scientific achievements, unite us in common purpose, or divide us along lines of belief and interpretation? The muted public response to ʻOumuamua might provide a preview of how humanity might react to more definitive evidence of extraterrestrial intelligence. But perhaps most significantly, ʻOumuamua challenges us to expand our awareness and improve our observational capabilities. If we've already missed one potentially artificial visitor, how many others might we be overlooking? The object's discovery has inspired new projects designed to detect and study interstellar objects, potentially opening a new window into the technological archaeology of our cosmic neighborhood. The Vera C. Rubin Observatory, currently under construction in Chile, will survey the entire visible sky every few days, potentially detecting numerous interstellar visitors that current telescopes would miss. Future space-based telescopes might be designed specifically to track and intercept such objects, allowing for detailed study that could definitively establish their natural or artificial origin. As you contemplate these possibilities, consider that we might be living through a historic transition period. The moment when humanity first becomes aware that we're not alone in the universe. But we haven't yet developed the technological and philosophical frameworks to fully understand what this means. Oumuamua might be remembered as the first messenger from a vast galactic community that we're only beginning to discover. This raises a crucial question about our cosmic future. If we are indeed part of a galaxy filled with technological civilizations, what should humanity be doing to prepare for more definitive contact? As we continue our exploration of humanity's possible first encounter with alien technology, we arrive at one of the most important questions facing our species. How do we find more visitors like Oumuamua? And what should we do if we detect something that's unambiguously artificial? The discovery of Oumuamua has fundamentally transformed how astronomers approach the study of interstellar objects. Before 2017, such visitors were purely theoretical. Scientists knew they must exist, but no human had ever actually observed one passing through our solar system. Now we know they're real, they're detectable with current technology, and they might be far more common than previously imagined. Dr. Avi Loeb has been at the forefront of efforts to systematize the search for artificial interstellar objects. His approach combines improved detection capabilities with rigorous criteria for distinguishing potentially artificial objects from natural phenomena. The goal isn't to find little green men or flying saucers, but to identify objects whose properties suggest engineering rather than natural formation processes. The challenge begins with detection itself. Most interstellar objects are small, dark, and moving at tremendous speeds relative to Earth. By the time we spot them, they're often already leaving our solar system, providing only a brief window for observation. Current survey telescopes like the Catalina Sky Survey, Linear, and Pan-STARRS were designed primarily to track asteroids and comets that might threaten Earth, not to detect exotic visitors from other star systems. This is about to change dramatically. The Vera C. Rubin Observatory, scheduled to begin operations soon, will revolutionize our ability to detect transient objects in the night sky. This facility will photograph the entire visible sky every few nights, creating a real-time movie of the cosmos that should reveal numerous interstellar visitors that current surveys would miss entirely. But detection is only the beginning. Once we identify a potentially interesting object, we need rapid response capabilities to study it before it disappears forever into the depths of space. This requires networks of telescopes that can be quickly redirected to track new discoveries, as well as space missions that could potentially intercept and examine interstellar visitors up close. The European Space Agency has already begun developing such capabilities. Their proposed Comet Interceptor mission is designed to rendezvous with a pristine comet from the outer solar system. But similar technology could potentially be adapted to study interstellar objects. The key challenge is speed. By the time we detect an interesting visitor, we might have only months or weeks to launch an intercept mission before the object moves beyond reach of current propulsion technology. Loeb and his colleagues have proposed more ambitious approaches, including networks of space-based sensors that could detect interstellar objects while they're still far from the Sun, providing years rather than months of advance warning. Such systems could potentially track visitors from the outer reaches of the solar system all the way through their closest approach, gathering unprecedented data about their properties and behavior. The criteria for identifying potentially artificial objects are based on the same principles that made ʻOumuamua so intriguing. Scientists look for statistical anomalies, properties that are extremely unlikely to occur naturally but would make sense for engineered systems. These might include unusual shapes, unexpected trajectories, anomalous accelerations, or spectral signatures that suggest artificial materials. But the search extends beyond simple detection to encompass what Loeb calls space archaeology, the systematic study of potentially artificial artifacts in space. This approach treats the solar system as an archaeological site, where evidence of past visitations might be preserved for extended periods. Unlike radio signals, which propagate at light speed and can easily be missed, physical artifacts remain accessible for study long after their creators have moved on. Space archaeology might focus on several different types of evidence. Impact craters on airless bodies like the Moon might preserve fragments of artificial materials that survived high-velocity collisions with planetary surfaces. Asteroid surveys might identify objects with unusual compositions or structures that suggest artificial origin. Even Earth's atmosphere might contain microscopic particles of artificial materials, deposited by ancient visitors. The search also extends to more exotic possibilities. If some interstellar visitors are actively controlled rather than derelict debris, they might exhibit behaviors that reveal their artificial nature more clearly than ʻOumuamua did. A probe that changes its trajectory in response to observation, or that begins transmitting signals after detecting our radio emissions, would provide much clearer evidence of artificial origin. Recent developments have added urgency to this search. Several additional interstellar objects have been detected since ʻOumuamua, including Tuidai Borisov, which appeared to be a more conventional comet with visible outgassing and a clear coma. But astronomers are now analyzing these new visitors with much greater attention to the possibility that some might be artificial. The statistical analysis of interstellar object properties is revealing intriguing patterns. If artificial objects are indeed mixed with natural ones in the population of interstellar visitors, we might expect to see a bimodal distribution. Two distinct groups with different characteristic properties. Natural objects would cluster around parameters expected for asteroids and comets, while artificial ones might occupy different regions of parameter space entirely. But perhaps the most significant development in the search for interstellar visitors is the growing recognition that this research might be one of our best chances for detecting evidence of extraterrestrial intelligence. Unlike traditional SETI approaches that require aliens to be actively transmitting signals in our direction, space archaeology searches for evidence that persists regardless of whether its creators are still alive or interested in communicating with us. The implications of finding even one unambiguously artificial interstellar object would be revolutionary. It would prove that technological civilizations exist elsewhere in the galaxy, that they're capable of interstellar travel, and that the space around our solar system contains artifacts that we can study directly. Such a discovery would instantly transform our understanding of our place in the cosmic community. As you contemplate this ongoing search, consider that we might be living through one of the most important scientific endeavors in human history. Each new interstellar object that enters our detection range might be the one that finally provides definitive evidence that we're not alone in the universe. The next Oumuamua could arrive at any time, and it might be even more obviously artificial than the first. But this search for cosmic visitors raises deeper questions about the nature of interstellar travel and the technologies that might make it possible. What can Oumuamua teach us about the engineering challenges of crossing the vast distances between stars? As we delve deeper into the mystery of Oumuamua, we encounter one of the most profound engineering challenges in the universe: how to travel between stars. If this enigmatic object truly represents alien technology, then studying its properties might provide our first glimpse into solutions for a problem that has seemed almost impossibly difficult: crossing the vast gulfs of space that separate stellar systems. The distances between stars are so enormous that they challenge human comprehension. Our nearest stellar neighbor, Proxima Centauri, lies 424 light-years away, roughly 25 trillion miles. To put this in perspective, if Earth were the size of a grain of sand, Proxima Centauri would still be over 4,000 miles away. Using our fastest current spacecraft, New Horizons, a journey to the nearest star would take more than 70,000 years. These vast distances create engineering challenges that push against the fundamental laws of physics. Any interstellar spacecraft must survive the journey through the incredibly hostile environment of space, bombarded by cosmic rays struck by microscopic debris traveling at relativistic speeds, subjected to the slow decay of radioactive materials and the gradual degradation of all physical systems over geological timescales. If Oumuamua represents the solution to these challenges, then its properties become incredibly revealing. The object's extreme thinness, potentially just a few atoms thick, makes perfect sense from an interstellar engineering perspective. To accelerate a spacecraft using light pressure alone, you need to minimize mass while maximizing surface area. The thinner the sail, the greater the acceleration achieved from stellar radiation. But creating such an ultra-thin structure that can survive interstellar travel represents an engineering feat that borders on the impossible with current human technology. The sail would need to be lighter than gossamer, yet stronger than steel, flexible enough to unfurl across vast distances, yet rigid enough to maintain its shape under the pressure of starlight. It would need to resist the corrosive effects of cosmic radiation, the heating and cooling cycles of passing near different stars, and the constant bombardment of interstellar dust and gas. The materials science required for such a structure might involve technologies we haven't yet discovered. Perhaps the aliens who built Oumuamua learned to manipulate matter at the atomic level, creating metamaterials with properties that emerge from their precisely engineered structure rather than their chemical composition. Such materials might be lighter than any natural substance while possessing strength and durability that seems impossible from our current perspective. The object's tumbling motion also provides insights into interstellar engineering challenges. A functional light sail would need attitude control systems to orient itself properly relative to stellar radiation sources. The fact that Oumuamua appears to be tumbling randomly suggests either that it's a derelict whose control systems have failed, or that it represents a different approach to interstellar travel entirely. Perhaps the tumbling is intentional, a way to average out the radiation pressure from different directions over long periods. preventing the sail from being pushed too far off course by the complex gravitational and radiation environment of the galaxy. Or, perhaps, the tumbling motion helps protect the structure from damage by presenting different surfaces to the destructive effects of cosmic rays and interstellar debris. The engineering philosophy behind ʻOumuamua, if it is indeed artificial, might represent a fundamentally different approach to space exploration than humans typically envision. Rather than building massive, complex spacecraft designed to carry crews or sophisticated instruments, an advanced civilization might deploy vast numbers of simple, lightweight probes, each one barely more complex than a smart material that can navigate between stars and gather basic information about any planetary systems it encounters. This swarm approach to interstellar exploration makes profound sense from an engineering perspective. Instead of putting all your resources into a single expensive mission that might fail, you could launch thousands or millions of simple probes, accepting that most will be destroyed or lost, while ensuring that some survive to complete their missions. It's a strategy inspired by biology, the way plants release vast numbers of seeds, knowing that only a few will find suitable conditions to grow. Such probes might be designed with minimal complexity to maximize reliability over interstellar distances. They might have no moving parts, no complex electronics, and no active propulsion systems beyond their light sails. Their intelligence might be distributed throughout their material structure rather than concentrated in vulnerable computer systems. They might communicate not through radio transmissions, but through their physical properties, encoding information in their shape, composition, or trajectory that can be decoded by anyone sophisticated enough to detect and study them. The longevity requirements for interstellar missions create engineering constraints unlike anything we've encountered in human technology. These artifacts must function across timescales that span multiple stellar lifetimes. They might need to survive the deaths of the stars that launched them, continuing their missions across geological ages that see entire civilizations rise and fall. This temporal perspective suggests that interstellar probes might be designed more like geological formations than technological devices. They might be engineered to evolve and adapt over time, using the materials and energy they encounter during their journeys to maintain and even improve themselves. Such self-repairing, self-improving systems might gradually transform during their travels, arriving at their destinations as entities quite different from what was originally launched. The possibility that ʻOumuamua represents this kind of evolved ancient technology adds another layer of mystery to its properties. The object we observed might bear only distant resemblance to the probe that was originally sent by its creators. It might have been rebuilt, modified, and adapted countless times during its journey through interstellar space, potentially incorporating materials and design principles from multiple star systems. From this perspective, studying objects like ʻOumuamua becomes a form of technological archaeology that might reveal not just the engineering capabilities of their creators, but the history of their journeys across the galaxy. Each interstellar visitor might carry within its structure a record of the stellar systems it has encountered, the materials it has incorporated, and the modifications it has undergone during its cosmic odyssey. As you contemplate these engineering possibilities, consider that we might be witnessing the results of technological development paths that diverged from our own millions or billions of years ago. The solutions to interstellar travel, represented by objects like ʻOumuamua, might point toward futures for human technology that we've never imagined, ways of exploring the galaxy that rely on patience, persistence, and engineering approaches that work with natural forces rather than against them. This brings us to our final and perhaps most profound question. What does the possible existence of interstellar visitors like ʻOumuamua mean for the future of human civilization and our eventual journey to the stars? As we approach the end of our journey through the mystery of ʻOumuamua, we arrive at the most profound implications of all. What does this possible first encounter with alien technology mean for humanity's future? How should the knowledge that we might not be alone in the universe change our approach to science, exploration, and our ultimate destiny among the stars? If Dr. Avi Loeb's hypothesis is correct, if Oumuamua truly was an artificial object created by an extraterrestrial civilization, then humanity stands at one of the most significant threshold moments in our species' history. We've crossed from a universe where we could only speculate about the existence of other technological civilizations to one where we have physical evidence that such civilizations not only exist, but have developed capabilities that allow them to send artifacts across the vast distances between stars. This transition fundamentally changes our cosmic context. We're no longer a lonely species struggling to understand our place in an apparently empty universe. Instead, we become junior members of what might be a vast galactic community of intelligent beings, each following their own evolutionary and technological pathways toward greater understanding and capability. The implications for human science are staggering. If interstellar space is populated with technological artifacts from various civilizations, then we have access to a cosmic library of engineering solutions developed over millions or billions of years by species with radically different evolutionary backgrounds. Studying these artifacts might accelerate human technological development by thousands or millions of years, providing insights into physics, materials, science, and engineering approaches that we might never discover on our own. But this knowledge comes with profound responsibilities. If we're being observed and studied by advanced civilizations, then our behavior as a species becomes a kind of cosmic performance. How we handle conflicts, environmental challenges, and technological development might influence how other civilizations choose to interact with us, or whether they choose to reveal themselves at all. The possibility that Oumuamua was a reconnaissance probe raises particularly intriguing questions about cosmic protocols. If advanced aliens are indeed studying developing civilizations like ours, they've clearly chosen a path of non-interference, allowing us to evolve technologically and culturally without direct intervention. This suggests the existence of something like a cosmic anthropological ethics, principles that govern how advanced species interact with less developed ones. From this perspective, humanity might be undergoing a kind of cosmic examination. Our response to challenges like climate change, nuclear weapons, artificial intelligence, and genetic engineering might be tests that determine our readiness for more direct contact with galactic civilization. Species that successfully navigate these challenges might be welcomed into the cosmic community, while those that fail might be left to develop in isolation until they're ready for greater responsibilities. The search for more interstellar visitors like Oumuamua becomes not just a scientific endeavor, but a crucial step in humanity's cosmic education. Each artifact we detect and study might provide lessons about technologies, materials, and engineering approaches that could revolutionize human capabilities. More importantly, the patterns we observe in these artifacts might reveal the structure and nature of galactic civilization itself. But perhaps the most profound implication of Oumuamua involves humanity's own future as an interstellar species. If other civilizations have mastered the technologies needed to send probes across the distances between stars, then such journeys are clearly possible. The engineering challenges that seem insurmountable to us today might have elegant solutions that we simply haven't discovered yet. The light sail hypothesis suggests one possible pathway for human interstellar exploration. Rather than trying to build massive spacecraft capable of carrying human crews to other star systems, we might follow the example of Oumuamua's hypothetical creators and develop swarms of lightweight probes that can reach nearby stars using nothing more than the pressure of sunlight for propulsion. Such probes might carry miniaturized sensors, artificial intelligence systems, and even self-replication capabilities that would allow them to establish permanent human presence in other star systems without requiring the transport of biological humans across interstellar distances. These technological descendants of humanity might explore the galaxy for millions of years, sending information back to Earth and potentially preparing suitable worlds for eventual human colonization. The timeline for such developments might be shorter than we imagine. Advances in artificial intelligence, nanotechnology, and materials science are proceeding at exponential rates. Within decades, we might have the capability to design and build interstellar probes that dwarf anything we could accomplish today. Within centuries, we might join the community of species that populate interstellar space with their technological artifacts. But this cosmic future also requires fundamental changes in how we think about exploration, communication, and the meaning of intelligence itself. Interstellar travel demands patience measured in geological time. Missions that span thousands or millions of years, conducted by artificial intelligences that might evolve and develop their own goals and purposes during their journeys. This long-term perspective challenges us to think beyond the immediate needs and desires of current human civilization toward the ultimate destiny of intelligence itself. If consciousness represents the universe's way of understanding itself, then the spread of intelligence throughout the galaxy might be the cosmos evolving toward greater self-awareness on the largest possible scales. The possibility that we've already encountered evidence of this process in the form of ʻOumuamua transforms our understanding of our cosmic role. We're not just observers of the universe, but participants in its ongoing evolution toward complexity and awareness. Our scientific achievements, technological developments, and eventual expansion beyond Earth contribute to the universe's growing capacity for self-understanding. As you drift toward sleep contemplating these vast possibilities, consider that you might be living through one of the most important transitions in cosmic history. The moment when humanity first becomes aware of our participation in a galactic community of intelligence. The quiet passage of ʻOumuamua through our solar system might be remembered as the event that changed our species' cosmic perspective forever, opening our eyes to possibilities we had never dared imagine. Whether ʻOumuamua was natural or artificial, its brief visit has expanded our vision of what's possible in the universe. It has reminded us that the cosmos is far stranger, more complex, and potentially more populated than we ever suspected. And it has challenged us to prepare for a future where humanity takes its place among the stars, contributing our own unique perspective to the ongoing conversation between intelligence and cosmos that might be unfolding throughout the galaxy. As we reach the end of our investigation into one of the most mysterious objects ever to visit our solar system, remember that ʻOumuamua's greatest gift might not be the answers it provides, but the questions it forces us to ask about our place in the universe. Whether it was an alien light sail, a natural ice fragment, or something else entirely, this enigmatic visitor has opened our minds to possibilities that seemed like science fiction just a few years ago. If this exploration of humanity's possible first contact with extraterrestrial technology has expanded your cosmic perspective, make sure you're subscribed and hit that notification bell. Because the universe is full of mysteries waiting to be discovered, and the next interstellar visitor could arrive at any moment with even more profound revelations about our cosmic neighborhood. Sweet dreams, and remember, you're living in an age when humanity is finally developing the tools and wisdom to recognize that we might not be alone in the universe. The next time you look up at the stars, consider that somewhere out there, other forms of intelligence might be looking back, perhaps wondering if we're ready to join the cosmic community they've been building for millions of years.